through it really quick. So this method in particular, the router.post, for the post/id/comments. All right, so this one's a little bit complicated because you got to do a couple different things. So first you validate the body. All right, you got to validate that request body, make sure it's expected, make sure the data's expected. If the validation passes, then you can go ahead and find the post by ID as the first thing, right? Because we can't create a comment for a post that doesn't exist, so we got to make sure it exists first. So we call post.findById. Okay, and then in the callback of that promise, we're going to get the post back. In this case, you got to destructure it because I'm assuming that that method returns an array. So we just destructure it for the first one and get the post. Once we verify that the post is actually there, it actually exists, then we can go ahead and insert the comment for that post. By doing that, you just call posts.insert comment, and then you pass the request body that came through. You're actually merging it into this object with the post ID itself. So then you take the post ID again from those URL params and you merge it into one single object along with the request body, and then you send that to the function, and that's actually what gets created. So you're essentially creating like a relationship, right? You're creating that comment, but you have to specify the post ID on that actual data that's created, that's sent to the database. And then last but not least, you gotta actually return that comment from the database so that you can return it to the response. So you request it by the ID that comes back from that insert comment function, and then you return it with 201 status and the JSON method. This one gets really, really ugly using promise chains, especially in this case. Actually, this isn't implemented correctly. There's too many .thens and .catches. But even if it was implemented correctly, there would still be a lot of weird stuff going on with these promise chains. So this is where using something like async await might help out quite a bit. Like I said, we're going to talk about async await probably on Wednesday. But if you want to learn about it in the meantime, it could probably help clean up this project quite a bit, especially this method. All right. Does that clear it up? Whoever asked to look at that. Async await, is that what I? Yeah, it's called async await. It's just a different way of writing promises. Yep. 2 words, async and await. We'll go over that on Wednesday, hopefully. All right, any other questions before we get started? How do we know that we need to destructure the array or the object? Destructuring is always optional. Okay, destructuring is just one of those things that's kind of like, it's just syntactic sugar. If you know what syntactic sugar is, it's just syntax that makes our code look a little bit better, a little bit cleaner. Destructuring doesn't actually do doesn't have any performance optimizations or anything under the hood like that. It's purely syntactic sugar. Okay, it's just for looks. It just makes our code look a little bit cleaner when we destructure stuff versus when we just use the objects directly. So destructuring is always optional. If you'd rather just use variables and not destructure anything, you can totally do that and it would still work just the same. But sometimes destructuring can make your code look a lot cleaner. All right. So make sure you get the project cloned down and installed. Tonight we're going to be talking about middleware. Okay, middleware, it's not a new term for us. We've heard it. We've heard middleware before. Where have we actually used middleware before? Hopefully that word rings some bells. Where have we used middleware before? In Redux, right? Yeah, we used middleware a lot in Redux. this is a diagram I like to show students when I'm teaching Redux middleware specifically. So Redux middleware is the functions that sit between the action and the reducer, right? And they can manipulate the action before they go to the reducer. So how would you explain the concept of middleware? From what you know, or from how you've used it in Redux and what you know so far, how would you explain the concept of middleware? Answer in the thread. Give me like one sentence, maybe two sentences of how you would explain the concept of middleware. Not specific to any programming language, but just the concept overall. Okay. Intercept the action and make async calls, a function that helps perform a specific task, a set of functions that extend your app. Perfect, yeah. So middleware is really, when you come down to it, when you're talking about just the concept, not the specific implementation, but the concept. Middleware is just a function or a set of functions that intercepts a process, right? It runs some code, changes some stuff, and then it continues or doesn't continue with that original process. So it's like an injected process, right? It's hijacking that original process and it's running some specific code and doing some different things, right? That's middleware. Remember that middleware, it's a programming concept that applies to many different languages and environments. It's more of a concept rather than like a feature. So we learned about it in Redux. We spent a lot of time in it when we were using Redux middleware, but surprise, it can actually be used a lot in the backend as well, this concept of middleware. So since Express, it actually isn't a fully fledged framework. Like a lot of the other frameworks out there, it's more minimalist. It takes a simple approach to things and it leaves a lot of implementation details up to us as the developer. So out of the box, Express, it provides a lot of great helpers for things like routing, request body parsing, query string parsing, all of those things that we've seen so far, right? But for everything else that we need to do with Express in our backend, we can essentially extend the core functionality of Express with middleware functions, okay, with this concept of middleware. So you'll find as we move along in our backends that most of the custom code we write for Express will take place in these middleware functions. Okay, this is how we customize our Express application. It's actually a lot easier to implement than Redux. If you remember implementing middleware in Redux, it was pretty complicated. You have to like install all these libraries and create all these instances and pass like all this weird stuff to it. In Express, it's actually really easy to define middleware. It just supports it out of the box. Okay, it's kind of part of the whole paradigm of Express. So we don't really have to do any additional configuration or setup. Middleware is just supported by default. So we're actually already using some middleware. Okay, we've already used some middleware in our previous projects. Who knows where the middleware is? If you pull up our guided project for tonight, you can just clone it down from this endpoint. Look at our guided project and open up index. Where are we already using some middleware? Express.json, right? This is middleware. This is built-in middleware from Express that we're using to parse JSON requests. Okay, where else have we already defined some middleware? Okay, I'm not sure how to say your name. I'm going to try. If I butcher it, I apologize. Arun Bold? Oh, I'll just call you Arun for short, or Bold for short. He got it. Okay, so another place that we're using middleware is our route handlers. The router, right? Since all request handlers in Express are considered middleware, our route handlers, like our welcome router, our hubs router, if we look at those files, these are middleware functions as well. Okay, our entire application, our entire Express application is essentially just a bunch of these middleware functions pieced together into an overarching application. Okay, so right now, the only middleware functions we've used are these route handlers, right, and the express.json. But we're going to go more into detail tonight as to how to create more custom middleware functions other than what we've done so far. So as you can see, when you call a callback function, or when you pass a callback function to Express and it uses the request and the response parameters, right, the homies, as Luis likes to call them, that is defining a middleware function. So any functions that are using the homies is a middleware function, including our route handlers. So if you were to look at express.json, if you were to look at the implementation of that function under the hood, it would be using the request and the response handlers, just like our route handlers. Okay, so the middleware stack in Express is essentially just an array of a bunch of these request handlers that run in order before the response is sent to the client. So let's take a look at another diagram. This is the middleware stack. Okay, this is what happens when someone comes to our web server and Express runs and creates a response and sends that response back to the user. Okay, it's just this array, essentially, of middleware functions that run to build that final response. So these handlers, they can do anything, right? These middleware functions, they can do anything. They can log data to the console, right? In the case of this logging middleware. They can authenticate a user, for example. Okay, they can parse some JSON, some JSON data from the request body, which is what express.json is doing. Okay, they could serve some static files. They could process a route and send a response, like our route handlers. Okay, that's our middleware stack. It's just this stack, this array of middleware functions that are going to run in order, one after the other, to build that response. So look at this arrow on the left. The request and the response objects, the homies, right? Those parameters, those get passed through our middleware stack as our response gets built. Okay, the same request and the same response object gets passed through to each middleware function. So I know that we've talked a lot about how immutability in our code is always a really good thing, right? We don't want to mutate data. But in this case, our request and our response parameters are actually mutable objects that get passed through this middleware stack. And the reason that they're mutable is so each middleware function can alter that request or alter that response before it gets passed to the next one, right? Because each middleware function has some part to play in shaping that final response. So as the request and the response get passed through this middleware stack, each one might be doing something a little bit different with it.
Yeah.
In this case, it's just going to log out some data, right, in the logging middleware. User auth, it might just get some data from that and make sure that the user is valid. JSON, it might get some data from that and maybe attach something to the request object. If the JSON parsing middleware, if that attaches something to the request, maybe the parsed JSON object, then our app routing middleware can access that same value because it's later in the stack, right? It's further down in the middleware stack. So this gives our code a lot of flexibility. Instead of just jamming all of this stuff into a single middleware function, into a single route handler, we can now split it up into different middleware functions and reuse them in different routes. Okay. So think of our middleware stack like an assembly line. Okay, we're all familiar with the concept of an assembly line. In this case, I think this is from the Tesla factory, one of the Tesla factories. Okay, think of the car, in this case, as our homies. Okay, the request and the response objects. And think of the red arms as our middleware functions. Okay, so when the request first comes in from the client, it's going to have some data, right? Or in this case, in the case of our assembly line, when it first comes through, it's going to be an initial stamped frame of a car. Okay, when it first jumps onto the assembly line. Now, as that frame, as it moves through the factory, the robot arms, the humans, whatever is in this assembly line is going to slowly build out this car, right? They're gonna add different pieces. They're gonna test functionality. They're gonna paint stuff. They're gonna add electronics, whatever happens on that assembly line. Just like how our Express app is slowly building response as the request moves through the middleware stack. Okay. Now, once the car reaches the end of the assembly line, it's ready, it's built, and it's ready to be sold, right? It's a completed car. In our Express applications, when our request reaches the end of our middleware stack, once everything has processed it and everything's looked at it, then that HTTP response, it's ready to be sent back to the client. Okay, so think of middleware like an assembly line for our response, for that response. Okay, any questions so far? Do all programming languages have middleware, or is it only Node? Middleware is more of a concept than a feature, right? It's not language specific. Middleware is used in all different languages, all different platforms. It's just a concept. So yes, all programming languages have the concept of middleware, some kind of implementation of middleware. All right, so there's actually 4 different types of middleware in Express. Okay, the first type of middleware is built-in middleware. Okay, which is like express.json, that express.json call. That's a function that we didn't have to define. We didn't have to npm install it. It just came from Express. It came from the Express library itself. Okay, so that's built-in middleware, something that we just use and it just works. There's actually a lot of different types of built-in middleware that come with Express. If you look at the documentation, okay, you can look under this Express, under the application tab, and you can see all these different types of middleware. All this stuff that we can call in Express. Oh, here, that's what I was looking for. So that's the built-in middleware functions that come with Express. Okay, we've got express.json, which we've already used. Express.raw, express.router, express.static, .text, .url encoder. These are all built-in middleware functions. Okay, make sure you keep your microphone muted. Okay, the second type of middleware is third-party middleware. Okay, third-party middleware, which when we use it, it's a lot like the built-in middleware, right? We just call a function. But in the case of third-party middleware, you actually have to install it with npm. Okay. Third part of middleware, or third type of middleware, is custom middleware. which is middleware that we write ourselves. Okay, we're gonna see how to do that tonight. And last but not least, we have error middleware. Which allows us to catch errors in other middleware functions. And we're gonna talk about this one at the end of the lecture tonight, error middleware. So that's our 4 types of middleware. So we've already seen built-in middleware, right? We've used that express.json function. Let's take a look at how to use some third-party middleware. First one we're going to look at is this middleware called Morgan. So open up this link and let's look at the documentation. So Morgan is an HTTP request logger middleware for Node. In other words, it's a piece of third-party middleware that we can install that will log out HTTP requests as they come in. It'll log out the details, right? It'll log out like the IP address of the client and the method and the route and things like that. The response time, okay, all these useful things. So if we want to install this third-party middleware and use it, it's really easy. All we do is install Morgan. So we're going to go into our terminal and we're going to say npm install -- save Morgan. Okay, let that install. And then we're going to jump into our index file in our guided project tonight. Then we're just going to import it. So right below express, just say const Morgan equals require Morgan. So we're importing it into our application. Now you probably noticed if we ever want to use middleware, we literally just say server.use and then we pass the middleware. So in this case, if we want to use Morgan, just come right up above express.json and say server.use and then call the Morgan function. That's going to use some third-party middleware. If you look at the documentation, you'll see that you can pass through different formats for our logging. So you can pass through a predefined format of tiny is an option. Or combined is an option, or common, or dev, or short. I like the short one, so let's pass through short as our option to Morgan. Let's just say Morgan with the option of short, and save that, and start your server. Okay, so now if we start the server, say npm run watch, that watch script that we set up on last week, it's going to be running on localhost port 4000. And just go to that in your browser, localhost port 4000. Okay, we get our welcome message. Welcome to the Lambda Hubs API, but now go back into your terminal and look at what happened. We got 2 log messages. We got a get root / HTTP1, status code of 200. The response took 3 milliseconds. This is our IP address, which is shorthand for like 127.0.0.1. That's the IPv6 version of localhost, basically. And you see our browser also made a request to our API for the favicon. That's just something that browsers do by default, which is kind of weird. if you go to port 4000 / some route, try to go to /API to get our welcome to our Hubs API and JSON message. Go back to your terminal and you see it logged that request as well. So now anytime someone comes to your API and makes a request, it's going to log out their details to the console. So you can kind of monitor how many people are using your API, what their IP addresses are, things like that. That's a lot of cool functionality that came by just installing some third-party middleware. Okay, let's try and install another piece of middleware. Before we do that, jump into Insomnia. Open up Insomnia or Postman or whatever you're using to make requests. And make a GET request to API/hubs, that same route that we set up before, just to list out all of our hubs. Make a request, make sure you get a 200 OK. But then go to the header tab. Take a look at the response headers. So there's one header in here in particular, one response header that's kind of concerning. And that's the X powered by Express. The tech stack that you're using behind the scenes. Okay, you don't really necessarily want to broadcast to the world that you're using Express for your API. And type in how to add headers with Express. All right. Any other questions about using third-party middleware? How are we feeling so far? Make sure you update your live poll in Slido. All right, let's talk about custom middleware next. So that's third-party middleware. We talked about built-in middleware, third-party middleware. Let's talk about custom middleware. We've actually already written custom middleware in the form of our route handlers, right? Remember our route handlers, they're considered middleware, just the end of the stack, right? These route handlers, this is middleware, just at the end of the stack. There's nothing that comes after them. But let's create another custom piece of middleware. So jump into your index file. And a really, really simple example of custom middleware could be a 404 route. Okay, calling a route handler if no route exists. Currently, if we try to go to a route that doesn't exist, try going to port 4000 / hello. You're going to get a 404 not found status code and this plain text response that just says cannot get hello. Okay, that's something that Express does for us by default under the hood. But what if we wanted to send a custom response to the client for a 404? So we get something that's a little better than just that plain text response. Well, we can create some custom middleware. So we're going to go down to the bottom of our stack. So in index, after all of the other server.use functions, we're going to call another one. We're going to say server.use, and we're going to create a custom middleware function. It's going to look the same as our route handlers, right? It's going to have the request and the response as a callback. And inside of this middleware function, we can just say res.status 404. And instead of returning that plain text response, let's return some JSON. Return a JSON object that says message route was not found. And now see what happens when you go to that hello route, the route that doesn't exist. We should now get our route was not found object. So now we're customizing that response. Okay, that's our first custom middleware function. Since this is kind of a catch-all, it's kind of like a catch-all piece of middleware, it should potentially run for any route. We're not defining a route like we do with our route handlers. Okay, we don't define a route, it's just a kind of like a global piece of middleware. Okay, why doesn't our 404 middleware function, why doesn't this function, this middleware function, why doesn't it run unless a previous route is never matched? So for example, if we go to get hubs, right, that's not going to trigger our 404 response. That's going to trigger 200. And 404 never gets run at all. But if we go to a route that doesn't exist, then our 404 is going to get triggered. Why is that? Okay, it's an important piece, an important detail about middleware that we just discussed a few minutes ago. Why doesn't that 404 get called if a route is matched, if a route is found? Order of operations, right? It's on the bottom of the stack. Last in the stack. Exactly. Yep, you guys got it. We're defining that custom middleware, that custom 404 middleware. We're defining it at the bottom of the stack, right? All the way at the bottom, after our router, after our routing middleware. So it's essentially sitting right here. Okay, and middleware functions are always going to run in the order that they're defined in. Okay, always going to run in the order that they're defined in. It'll kind of waterfall down this stack. So if one of these middleware functions decides to end early, if they don't decide to move on to the next piece of middleware, then they can essentially just end the response, and then all of the middleware functions afterwards never run. Okay, that's what's happening with our 404. When our middleware stack reaches the router, it finds that there's no suitable route, right? There's no route that matches the current URL, and it kicks it on to the next piece of middleware, which in this case is our 404 handler. But if a route is found, then the app routing middleware, that route handler, is going to send the response, and it's going to stop that middleware stack from running any further, which means it never even reaches our 404 middleware that's at the very bottom. Okay, so at any point in our middleware stack, one of these pieces of middleware can return a response and not continue with the rest of the middleware. It can stop the request in its tracks. Maybe if you have like a client error that you want to return, like a 400, or some other type of error, maybe an authorization error, they can cancel that request and send a response early before it moves on to the next pieces of middleware. Okay, let's look at a more complex example of custom middleware. Actually, let's take a quick 5-minute break before we jump into that. So take 5 minutes, let this all sink in, mess around with it, and I'll see you in 5. Okay. Everyone doing okay so far? Let's see, a question from Slido. Can we use comment index 0 instead of destructuring? Yes. So if you were to have a variable that was like, or maybe strings that was like 1, 2, 3, you could say const1 equals array at index 0, or you could say const1 equals array. Same thing, okay? It's optional to destructure if you prefer that syntax. If not, you can just use the index like this, or if it's an object, you can use the dot something. It's up to you, okay? And destructuring is always optional. Would you have a separate file for all middleware? Yeah, yep. If you get to the point where you have a lot of different middleware functions, a lot of custom middleware functions, as you'll see tonight, we're actually going to do this. We're going to start to separate them into separate files and just importing them into index. Yep. All right, so let's look at a more complex example of custom middleware. What we're going to do is we're going to copy the functionality of this Morgan library, okay, of this logging middleware. Let's build that from scratch. So let's create it in a new file. So create a new file, actually create a new folder, and call it middleware. Okay, and then inside of the middleware folder, let's create a file, and we're going to call it logger.js. Oops. Create a file called logger.js inside of a middleware function. Okay, so first thing we need to do is export a function, right? So let's say module.exports. And we need to export a middleware function, which, if you remember, is just a request and a response. So we're just going to export that function. Now, if you look at the Express documentation again, there's a lot of useful stuff on the request object, on this REQ object, that we can log out for every request. So let's take a look at that. Let's look at some of the things we can log out. Okay, we could log out like the base URL, or the request body, or the IP address. Okay, we could log out the method, or the params, or the path, or the protocol, the query. A lot of useful stuff we could log out for each request that comes in. Let's choose a couple of these. Let's log out the IP address. Obviously, that'll be a useful one to see. So we can log out the client's IP address when a request is made. Let's log out the method, the request method. So whether it's a get or a post or a put. let's log out the path. Okay. So we can see what path people are visiting. Let's log out, let's also log out the user agent header. Okay, if we want to get a header from the request, the user agent header, let's log that out as well, which we can use just req.get for that. All right, let's implement that. So let's go into our middleware, and we're going to say, first get the IP address. So we're going to say IP equals request.ip. Okay, get the method. Get the URL or the path. And get the user agent header. So we can say const agent equals request.get user agent. User agent is just a header that clients send to basically say what type of client it is, whether it's a browser, whether it's Safari or Chrome or Firefox, or whether it's Insomnia, or whatever client is being used to make that request, we'll usually send a user agent header. And it's just a string, like some kind of a unique string. You'll see what it looks like. Okay, we could even destructure those 3 variables above to clean it up a little bit if we wanted. We could say const IP, method, and URL. Get all of those from the request. That shortens it up a little bit. And just log it all out in a string in one line. So let's say console.log, and let's build this line. So create a template string. Let's log out the IP address first. So we'll say IP. Then let's log out the method and the URL and the agent. Okay, how do we get that into our main application, and how do we use it? Post it into Slack. How do we import this into our index and use it as middleware? Okay, good, Matthew. Shrug. Let's import. Let's do it right below helmet. Let's import our logger. So we can say const logger equals require dot slash middleware slash logger. And how do we use it in our middleware stack? We can actually comment out Morgan because we're going to be replacing the functionality of Morgan. So let's comment that out. How do we use it in the place of Morgan? Server.use logger. Good, Ricardo. Remy. Server.use logger. Okay, how come we don't call it as a function like we did with our other middleware functions? How can we just pass the variable instead of calling it as a function? Any ideas? In all of our other middleware functions, we're calling the function and then passing the result of that function to server.use. Good, yeah, in this case, our middleware function, it's not taking any kind of param or anything. It's not returning the route handler or the middleware handler. It's just exporting it directly. So we just use it directly. But our middleware is probably going to want to be able to take some params. Like for example, when you call Morgan, you can define a logging type, right, or format. If we want our middleware function to be able to take that parameter, we just have to change up our export a little bit. And instead of exporting the actual middleware function, we have to export a function that returns the middleware function. Okay, a higher order function, an HOF. So if we wanted to do that, instead of exporting just directly, we can just export a function that returns our middleware function. And that way we can pass options if needed. So now when we call it, instead of just passing logger, the variable, we can actually call the function as such. Let's try it out. Save that and then go into Insomnia and make a request to any route. I'm going to get rid of that 404. Let's make a request to get hubs once you start your server. I always forget to do that. Something interesting happens, right? If you try and make that request, it's just going to hang. It's never going to close. We're going on 15 seconds and it still hasn't closed, right? That's a lot of time for a local request that's not even going over the internet. It's because our middleware, our custom middleware logger, it never moves on specifically to the next piece of middleware. Okay, that's because middleware functions in custom middleware. And now inside of our middleware, we can log out different formats depending on that parameter. So we can say if format is equal to short, then log something, otherwise log this one by default. Right, so maybe if our format is short, we only want to log out the method in the URL. So then we would just say, if the format is short, then just log out the method and the URL. Otherwise, log out the IP address, the user agent, everything else. Okay, so now if you try that out, so we're defining the format of short. So now when we visit our API, we should get a short log message instead of the log one. We should just see the method and the URL, right? So now if we try and make a request, make a couple of requests, go into the terminal, and we're still getting the long one. Did I miss something? Oh, I didn't save the file. Save the file and now try it out. Okay, so now if we visit it, we get the short log. But maybe we want the long one instead. So if we wanted the long one, we could just leave that parameter out and just let it default. Right, so now if we just change that, we don't have to change our middleware implementation at all. We're just changing the parameter and it changes up how our requests are logged. So now if we try and go to it, we get the long version. Okay, we're changing the functionality of our middleware by just changing the parameters. We don't actually have to change any code inside the middleware itself. Cool. So why don't we ever call, back to that next parameter, why don't we ever call that in the route handlers? Why don't we ever call next in our route handlers? Any ideas? Because the request is resolved by the status, right? The route terminates itself. Order of operations. Yeah, exactly. It would skip it, right? We don't call next in our route handlers because our route handler is the bottom of the stack. We never want anything else to run after our route handler runs. So for example, in our hubs router, we're sending res.status to 200.json. We're sending the hubs data, and that closes the request, right? That actually sends it off over the internet to the client. We don't want any other middleware to run after that, so we don't have to call next. Okay. We only have to call next if we're in other middleware functions that have to specifically tell the router or tell Express that they're done. Go ahead and move on to the next piece of middleware. There is no next piece of middleware after the router. Okay. What would happen if we called next? With our current setup, what would happen if we called next in our router, in our route handler? Think of our middleware stack, how it's set up currently. What would happen if we called next? After sending a response. It would actually try to return a 404. Right? Remember we defined a 404 middleware at the end of our middleware stack, right here below the routers. If we tried to call next in one of our routers, it's going to try and run this middleware, and it's going to try to send a 404 after it had already sent a 200. Right. So now we could essentially publish this module. We could pull this out into its own project and publish it to NPM. And then people could install it and use it just like we were using Morgan. Right? This is essentially what Morgan does under the hood. It defines middleware like this. What would happen if we put next in the 404 router? If we called next in the 404 middleware? In this case, nothing. Since there's nothing else after that piece of middleware, there's nothing else in the stack, it just wouldn't do anything. Express would say, all right, we're at the end of the middleware stack, there's nothing else to run, we're done. So question, we put logger below helmet, but Morgan above helmet. Is there a certain reasoning for this placement? Nope. In this case, the order of middleware doesn't necessarily matter because the logger middleware isn't dependent on the helmet middleware. Helmet middleware is not dependent on the logger middleware. So we can order those however we want. But let's say that one of our route handlers, let's say that it depended on something from our helmet middleware. Well, in that case, you would have to call helmet first so that it could do whatever it needed to do with the request before it got down to the route handler. Right? That order matters if they depend on each other. If the middleware functions don't depend on each other, then you can define them in whatever order you want. Okay, we'll see an example later tonight as to when a piece of middleware would depend on another piece of middleware. I'll show you an example of that. So the stack follows the .use around. Yep, so the order of our middleware stack is defined by when we call server.use. So our middleware stack right here, logger comes first, and then helmet, and then express.json, and then our route handlers, and then our 404. That follows our order right here. So like our logger would be here, helmet would be somewhere around here, express.json is right there, our route handlers are right there, our 404 would be somewhere right here. Okay, so when the function returns something, when exporting, we can call that function where we import it. If not, we just use the function. Oh yeah, so just going back to the higher order function, I think we explained that again. If you're still confused about that, feel free to post another question. Should we worry about how large the stack gets, the middleware stack? Most of the time, no. It would take a lot of middleware functions to start to slow down. So I wouldn't worry about that at all. Do we have to use that user agent header for every request? No. User agent is optional. Sometimes the client doesn't send anything, and that's fine. In that case, it would just log an empty string. It just wouldn't log anything in our logging middleware. There's no strict requirements really when it comes to headers, both response and request. It's more of a convention that all of the browsers agree to, that all of the clients kind of agree to. So when you're working with response headers and request headers, you kind of have to just take it with a grain of salt, because sometimes they might not exist. So you have to be careful. All right. Any other questions with custom middleware? That's the gist of it. How are we feeling? Completely confused? Crystal clear? Just need to practice with it a little more. We don't have any ones or twos in the poll, so that's good. Is it typical to map these middleware actions out prior to writing the code or working them in as you go? That's completely up to you. That's up to your development style. If you prefer to write the functions before you use them, go for it. If you prefer to wait until you need them, go for it. Work however you enjoy best, however your team likes to work best. All right, let's take, actually, how are we feeling? You guys need a break or you want to keep going? Shrog wants to keep going. Tim wants a break. Ashley wants a smoke break. Aislinn wants a break. Greg, keep going. All right, let's take a quick 5-minute break and then we'll jump into some more middleware. Come back to me. Okay, we all feeling okay? Uh-oh, we got someone voting for one. Let's clear that up. If you have any questions, anything specific that we can help answer for you. So question, can we use middleware inside of other middleware? Yeah, yep. There's nothing stopping you from doing that. You would just have to pass through your request and your response and your next. So maybe inside of our logger, if we had like, we'll put all that back in. If like inside of your logger, you wanted to call another piece of middleware, instead of calling next, you could call like some other middleware. And you'd have to pass through the request and the response and the next parameter. Yeah, you could do that. There's nothing stopping you from doing that. You actually see that pattern a lot when you're building custom middleware. I'm sure you'll come across that at some point. Can I go over the file structure for the project if we have time? Yeah. All right, well, now that we know how to define middleware, let's go ahead and extract some of the logic that our application is using, some of the logic that's in our route handlers, stuff that's reused a bunch. Let's extract some of that into our own custom middleware functions and kind of clean things up a little bit. So I'm going to go ahead and close our logger. I'm going to go back to a single layout. Let's take a look at our hubs router. We have a lot of stuff going on in here. A lot of stuff that's actually repeated if you look closely. Okay, we call like, or we're calling find by ID a lot. We have a lot of endpoints that use the ID. And some of the endpoints that use the ID, we're not even checking to make sure that the ID exists before we use it. Like in our put route, we're not even checking to make sure that ID is valid. Okay, we left that out last week. But we are checking for the request body.name. Okay, we're doing that in the put. We're also doing that in the post. We have a lot of stuff that we're repeating. So when we define middleware, when we create custom middleware functions, we can use them as global middleware like we've been doing, right? We can call server.use and pass our middleware for the entire application, essentially. But we can also create middleware that's specific to one or two or a few different routes that's specific to a route. Okay, when we call router.get or router.post or router.put, we're essentially just defining a middleware stack for that endpoint. So right now we just have one piece of middleware for each endpoint, right? The route handler. But we can pass as many middleware functions into that stack as we want. And we just do that by adding middleware functions in the stack right after the route. So we can say middleware 1, middleware 2. We can call as many middleware functions as we want that's specific to that route. Okay, these middleware functions are not going to run for the other routes, only for this route. And they're going to run in order, just like our global middleware. So when someone comes to API/hubs, makes a GET request, it's going to run this piece of middleware, it's going to run this piece of middleware, and then it's going to run our route handler. So let's extract some of the repeated code in our handlers. Let's extract our hubs.findById. So let's go to the bottom of this file, our hubs router. Just go all the way to the bottom right before the export and create a function called validate hub ID. So I'm going to say validate hub ID. Now, what's the first thing we do when defining this middleware function? What do we need to return? The homies. It's actually a little more than just the homies now. We have the request and the response, but we also have one more. Next, right? I think Luis calls them the three amigos. So we can say return, we got the request, we got the response, and we got the next callback. So we're defining a higher order function that returns our middleware function. So now if we want to extract some of this stuff in that validate hub ID middleware function, let's extract like the find hub by ID. So let's say hubs.find by ID. And we can say request.params.id to actually get that ID. Okay, it's coming from the URL. It's going to return a promise, so we can say .then and .catch. It's going to return some hub data, the hub object. The catch is going to return an error. Let's go up to the get hub by ID endpoint. We can probably just copy most of this stuff from that. Yeah, see, we can copy most of the stuff just from this endpoint. So let's copy that error first thing, the .catch. Just copy that and then paste that into the .catch of your middleware. So if there's an error when we try to get a hub by the ID, there's a server error, just log it out and then return a 500. Actually, I wonder if I can open this twice. Don't think it'll let me do that. Yeah. Yeah, I wouldn't touch VS Code for anything. Because I don't like apps that run Electron. Electron means that you're running a desktop app that essentially packages the entire Chrome browser inside of every single application, so it runs extremely slowly, and it's all built in JavaScript when it probably shouldn't be. That's all I'll say about that. Actually, the only Electron app that I have to use is Slack. That's the only Electron app that I actually have to use. But other than that, I can usually get away with it. One day Slack will build a native application, and that'll be great. Okay, let's also extract our, let's see. So go back up to the get hub by ID, and let's extract the then callback. So that if statement, that if else, go ahead and copy that as well. Copy that into your middleware function. I am a big fan of simple, fast, efficient software. Call out a purist, call out whatever you want, I don't know. What do we need to change in this if statement? So we're saying if a hub exists, return a status of 200 with the hub. If it doesn't exist, return a 404. This is a middleware function, right? We don't want to send a response if we actually get the hub. That's dependent on the route handler, or it should be. So we don't actually want to do that. What do we want to do instead? This is a middleware function, right? So it's going to be reused in a lot of different places and a lot of different routes. We just have to call next, right? That's going to move us on to the next piece of middleware, or the route handler. So we're going to call next instead of sending a status of 200. Call next. And now look at all of that code that we don't have to repeat ever again. We don't ever have to repeat that code. So let's copy our function name of validate hub ID. Let's jump up to our get hub by ID route. And now instead of doing all this crap, we can just call validate hub ID as middleware. And then call res.status 200. Only we still have a little bit of a problem. So now we can call validate hub by ID the middleware. It's going to check the database to make sure the hub with that ID exists. If it does, it's going to move on to the route handler. If it doesn't, it'll return errors. But the problem still remains that once we validate that hub ID, we validate that it exists, and we call next, we still have to get that data in the next piece of middleware somehow, right? We don't want to have to call find by ID again. Remember, our middleware functions, they run like an assembly line for our response, okay? So at any time in our assembly line, at any time in our middleware stack, we can attach stuff to the request object, and it's going to be available in later middleware functions. So let's just attach the value of hub to our request in our middleware function. Go back down to our middleware function, and right before we call next, let's say request.hub equals hub. And once we attach that value of hub to the request, we can now just call request.hub, and it'll have the hub data that we need. Okay, it's kind of like shared context between all of our middleware functions, or all of the middleware functions that come after, I should say. So now, how do we access that in the get hub by ID endpoint? Instead of saying hub, we can now just say req.hub. Okay. Now, if we ever need to validate the hub ID or get the hub by ID and check that it exists in any other middleware, we can just call this middleware function instead of redefining all of this logic. So let's use it in our router.post ID messages. We can say validate hub ID to make sure that hub exists. Let's use it in our get messages. Validate hub ID. Let's use it in pretty much all of our routes that depend on that hub ID or that do something with the hub ID. We can just call the same middleware function. Do it in our delete hub. We can validate the hub ID to make sure it exists. Okay, do the same thing in our put request. Validate hub ID. Actually, we don't need it in our post request because that doesn't use the hub ID. And there we go. We just saved ourselves a ton of code that would have had to be repeated otherwise. Okay. Any questions about what we just did? Now, if we go to Insomnia, try saving your file, go to Insomnia and try to make a request with an invalid ID. Try like going to, or we'll make a request for get hub by ID. Call API/hubs/1 after you start your server. I don't know why I always forget that. So we get the ID of 1, that comes through okay. Try to get the ID of 10, that comes through okay. Try to get the hub ID of 50, and we get our 404, hub not found. Okay, and that logic is going to be duplicated in every endpoint that we use that middleware. So now if we try to, let's try to get hub message by ID. Try calling that endpoint, but try calling it with an invalid hub ID. And we get a 500. Why do we get a 500? Let's take a look at what it says. Undefined bindings detected when compiling first. Undefined column. Oh, interesting. Ah. Okay, interesting. Who knows why we got this error? Can anybody see it? So when we call this get hub or get message by ID with an invalid hub ID, we get this strange error coming from the database. Can anybody spot it? Message ID is not bound? No, that's not the issue. Okay, the issue is that, look at this, our endpoint is defining the hub ID. It's defining the param as hub ID. So you have to call request.params.hubID to get that ID. But our middleware function is trying to find it with just regular old ID, request.params.id. So it's trying to get something that doesn't exist from the params. How do we fix that? Could change the middleware. Maybe we could have the middleware accept a parameter that says ID param, right, as a string, and then we can look it up by saying params ID param. And then when we call it, we can say validate hub ID and pass hub ID as the param instead of ID. That would be one way to solve it. That's kind of odd, because then we'd have to go through all of our implementations of the middleware and call it with the specific ID or with the specific parameter. Quick fix, let's just change the ID in that endpoint to ID instead of hub ID. That'll fix it for now. But that goes to show that, that accepting parameters in our middleware is important for reasons just like that. All right, let's try that again. Try that endpoint. And we get a hub not found. Same as we get if we try and request a hub from this endpoint. Okay, that's logic that got reused. Okay, would you normally put validate hub ID middleware function in a separate file? Yeah, you totally could. And that actually, I probably should have done that because then we could have looked at them at the same time. Yeah, if you want to extract this function into its own file and then import it, you could totally do that. I'll do that before I push the code up so that we can see what it's like in GitHub to have that in an external file. Okay, the part where we extracted the object from validate hub ID to be grabbed through request.hub, that part didn't make sense. Can we go over that again? Sure. So let's walk through this. Let's think about our middleware stack. When we call API/hubs/ID, we try and get a hub by ID. Our middleware function validate hub ID, that's going to run, right? And that's going to make a database request. It's going to request the hub from the database, the hub data, and it's going to check to make sure it exists. If it doesn't, it's going to return like a 404. It's going to return an error, right? If it does exist, if it actually finds a hub with that ID and it's valid, it's going to call next and it's going to move on to our route handler, right? It's going to move on, it's going to move down the stack to the next piece of middleware. Remember, our middleware is a stack. So if this middleware function right here, let's say instead of static files, it's validate hub ID. And it finds the ID and it moves on to the actual router middleware function, or the route handler. That route handler, it still requires that hub data from the database, right? And it can do one of two things. It can re-request it from the database. It can make another database request, call that find by ID method again with the ID and re-request that hub from the database before it returns it. But that's kind of duplicating that process, right? Because we already requested it from the database in our middleware function. We don't want to request it again. Since our middleware function already has the data that we need, we just need to pass it from this middleware function to this middleware function. And since the request object is shared between these two, validate hub ID, the middleware function itself, it can attach stuff to that request. And then whatever that request looks like when we call next is going to get passed to the next piece of middleware. So in this case, it's going to move on to the route handler. And this request object right here is going to have the hub data under request.hub. We can just return it without having to requery the database, without having to call find ID again. Okay, hopefully that clears it up a little bit. All right, so we had a previous question from earlier. For custom middleware, how do we mutate the request object using spread, using the spread operator or object assign versus just directly assigning the value? So yeah, you could do that if you wanted to. instead of just attaching hub to request, you could say like request equals, do something like that. Although that's not super clear as to what it's doing. I mean, it is if you understand ES6 and if you understand this JavaScript syntax, but it's kind of confusing. So, I mean, yeah, you could do that, but I don't know. It's easier to just attach hub directly. You could also do object assign. That's just a more JavaScript syntax that does pretty much the same thing. Like you could do that. It's just kind of overcomplicating it in this case. So it's easier to just attach it directly to the request. But if you have some reason to use one of these other methods, feel free. What is a hub? I don't know. I honestly don't know. A hub, it's just like, I guess it's some generic resource. Yeah, I don't know what to tell you there. You could think of hubs as like, think of a hub as like a, I don't know, think of it like a lesson. Like in this case, a hub is a lesson, right? You're listing all of the lessons for backend. And each lesson has a name, right? We have API 1 lesson, API 2 lesson. So yeah, think of hubs like our lessons in backend, or our lectures. Each lecture in the training kit. I don't know why it's called a hub, but it is. All right. Take the next 4 minutes and let me copy this into Slack. Okay, take the next 4 minutes and create some custom middleware for validating the request body in the post endpoint for hubs and the put endpoint for hubs. Okay, so create custom middleware that essentially extracts this functionality of checking for the body.name. Extract that into its own middleware and use it for post and put. All right, I'll give you 4 minutes and then we'll do it together. Yep, we're going over error middleware. I'll do that right after this as our last thing. It's pretty simple, so. All right. Sure, I've got it. Anybody else? All right. Well, good job, Shirag. Let's go through this. So let's create another piece of middleware. I'm just going to create it right above validate hub ID. I'm going to call it validate body. Actually, let's call it validate hub data. It's a little bit more specific. Okay, we're going to return a middleware function. So we're going to return request, response, and next. And then what do we need to do? Just check to make sure. If you look at our put request or our post request, just check to make sure that request.body.name is not empty. So just copy that if statement from either of those and stick it into that middleware function. So we're going to say if the request.body.name, if it's falsy, then return a status of 400, missing hub name. Otherwise, just call next. Remember, when we return from a function, it doesn't move on to the rest of the code. So it'll never reach that next call, and it'll return the response. And that's it. That's all we need. So now we can just use that middleware function in all of the endpoints that need to check that data. So copy it and go use it in post hubs. So you can now call validate hub data, and you can get rid of that if statement and put it in our put request as well. You can put it before or after validating the ID, either or, since they don't depend on each other in this case. So put it in the put request and get rid of the if statement. Cool. What about request.hub equals hub in this case? Jules, we don't actually need it because we're not passing any data from validate hub data, right? This doesn't like get any data from the database or anything like that. It doesn't have to pass anything on to the rest of the middleware. It just performs a simple if statement. And if the if statement, if it goes into it, if there's no body.name, then it just cancels the entire request. So it never moves on to the rest of the middleware. Cool. So let's move on to the last piece of this, which is error middleware, the last piece of middleware. Light bulb moment for Jules. Nice. Love it when that happens. So error middleware is our fourth type of middleware. If you notice in our router, we have a ton of these catch statements. They're all over the place. A ton of these catch statements that return a 500 status, they all essentially have the same message, right? They vary depending on what triggered the error, but they're all essentially the same, right? All over the place. That's 4 lines of code in a bunch of different places that could be extracted into something else. And it's really annoying to have to include this in every single endpoint, right? Include these catch statements with these 500 responses. So error middleware, it actually helps us with this exact problem by just defining a single piece of middleware in our stack that can essentially catch any errors that occur anywhere above in our middleware stack. So think of our middleware stack like a promise chain, right? You're familiar with promise chains. Think of this like a promise chain. You can have as many like then callbacks. Think of each piece of middleware as a .then, right? And remember, if any of the .thens, if any of them reject, if any of those promises reject, it goes down to the catch statement, right? You're familiar with that, how promises work. Error middleware is the same way. If we define some error middleware here at the bottom of the stack, and any of these middleware functions above it, if any of those trigger an error, then they'll bump down to the error middleware, just like a catch statement. Okay, so in order to define a piece of error middleware, we just go into our index, and right below our server.use, let's create another piece of middleware. So we're going to say server.use, but this time we're going to have 4 parameters. Okay, so we've had 2 parameters with the request and the response. We've had 3 with next, but now we're going to have 4 with error as the first parameter. So we're going to say error, request, response, next. Okay, and Express knows if we define a piece of middleware with 4 parameters like this, then it's going to be used as our error middleware. So this catches our errors. How do we throw our errors from the middleware functions themselves? So like right now inside of, let's go inside of the very first route handler, the get hubs. We're just logging out an error if we get one and then returning a 500, right? That's how we're dealing with our essentially unknown errors. But if we wanted to throw an error in here that got sent to our error middleware, all we have to do is call next with an error. Just like that. Oops. And that essentially throws an error that's going to get caught in our error middleware. So if next gets called without any parameters, then it just moves on to the next piece of middleware as normal. If next gets called with a parameter, with anything, it doesn't matter what it is, if it gets called with a parameter, then it's going to get sent to the error middleware handler. So calling next with no parameters moves to the next piece of middleware. Calling next with a parameter moves to the error middleware. So now what we can do is take this console log error and returning that 500 response. Let's copy that and put it in our error middleware instead of our catch statements. So now we can take that out and we can put it in our error middleware. Change error to error, depending on how you name that parameter. And then you can just change the message to something generic. Like, I don't know, just say like something went wrong. Okay, you never want to return server-side error details to the client. You never want to say like, oh, this specific method doesn't exist or some error happened in this method. You don't want to expose those error details to the response. You just want to say something generic like something went wrong. I don't know, we're working to fix it. Please try again later or something. Because the more you expose to your client, the more details about your application you expose, the less secure it becomes, right? We want to try and hide these implementation details. So now instead of calling that log and the status in our catch statements, we can just call next with the error. And we can now do that every single place in our router that we're trying to send a 500 response. So we replace it in the get hubs route. Let's replace it in the post hubs route. We don't have to call all this anymore. We can just say next error. Do it in the put route, call next error instead of that catch. Do it in the delete route. See, we're cutting out a ton of code. It's awesome. Do it in the get messages route. Get message by ID route. Post messages route. You could even do it in our other middleware. So our validate hub ID, you can do it in there as well. Call next with error. Yep. And then make sure, I forgot to do this, but in all of these endpoints that you're calling next, make sure you define it in the parameters. So we just have a request and a response. We now have to add next. Quick tip, if you're in VS Code or Sublime, just highlight that chunk and just press Command D or Control D and just highlight every instance of it on this file. So now it's highlighted every instance and we can just change them all at the same time. Add next. And if you know JavaScript, if you've ever worked with these callbacks in kind of a clever way, you don't actually have to define the callback at all if you wanted to shorten this even more. Instead of defining a callback with error and then calling next with error, you can actually just pass next. That shortens it even more. But you don't have to. If you want to be a little bit more verbose, you can call it like this. All right, and that's it for tonight.